Welcome back, students. Let's talk about solving multi-step inequalities. We're going to be using the addition and multiplication property of inequalities in order to do this. We're just going to do it now with inequalities that require more than just a single operation to be done. So looking at A first, we got A divided by negative, or X divided by negative 2 plus 4 is greater than a negative 1. I've got two different things over here with my x. I've got the plus 4 term, and I've got that divided by negative 2. I need to eliminate both of those in order to get x alone. The way I pick which one I'm going to do is I think of PEMDAS, and I think about what order these would happen in, and then I do it backwards. Okay, so if I knew exactly what number x was, let's say x is a 10. First thing I would do would be to divide by the negative 2, and then after I would add the 4. So because of that, I now do it backwards. I'm going to deal with the plus 4 first, and we'll do its opposite, which is minus 4. Now 4 minus 4 is going to be 0. Negative 1 minus 4 is going to be negative 5. Okay, now we're going to deal with the divided by negative 2. The opposite of dividing by negative 2 will be multiplying by negative 2. Also, notice what just happened. The inequality has switched directions because we are multiplying by a negative 2 on both sides of this. So, negative 2 over negative 2 is going to become a positive 1x. And then the negative 2 times negative 5 will become a positive 10. So, x must be less than 10. In order to show all of our possible answers, we're going to write a number line and now put a circle at the 10. We do not fill in the circle because 10 is not a solution. We now need to show all the numbers x could be. X can be any number less than a 10, so it could be any of the numbers off to the left. All right, next problem. Once again, if we knew what c was, first thing we would do would be to multiply that number by 3 and afterwards subtract 2. So we're going to deal with the 2 first, since it would be the last thing we would do if we were evaluating. So add 2 to both sides. To eliminate that first, negative 2 plus 2 is 0, leaving us only with the 3c. Negative 11 plus 2 will equal negative 9. All right, now we need to deal with the 3. We are multiplying by 3. Opposite of that would be to divide both sides by 3. 3 over 3 is 1, leaving us with 1c. Negative 9 divided by 3 becomes negative 3. So c is less than or equal to a negative 3. To show all the possible answers, we write a number line. We put a dot at that negative 3. We filled it in this time because negative 3 is a solution because this has an or equals to line on it. Now c has to be less than the negative 3, so I draw my arrow going off to the left in the direction of those lower numbers. All right, now let's see how this is going to work if we've got a variable on both sides. Similar to equations, first thing I want to do is look to see if there's anything that I can simplify first. Now, I don't see that distributive property is going to simplify anything. I don't see any like terms, so I'm just going to go straight now to eliminating the variable from one side. The one I'm going to choose to do is the lower one, that 3x, so I will subtract a 3x from both sides of this equation, this inequality. So 3x minus 3x is just going to be 0. We've eliminated it from the right side, so now we only have an x over here on the left. 5x minus 3x's is just 2x's. We brought down the negative 6, and we brought down the 4. Now, we're going to be doing opposite of PEMDAS, just like I said. So we're going to take that minus 6, add a 6 to both sides. Negative 6 plus 6 is 0. 4 plus 6 is 10. Now we're multiplying by a 2, so we do the opposite and divide by a 2. 2x divided by 2 is going to be x. 10 divided by 2 is 5. so our final answer, x is greater than or equal to 5. All right, now we're going to talk about situations in which inequalities have special solutions. When we were doing this with equations, what that meant were equations that had no solutions or infinite solutions. Okay, so let's see what these are going to look like with inequalities. So for this first one, I do have the variable on both sides. I also notice I can do distributive property on this side to simplify it. So that's what I'm going to start with. I'm going to multiply this 2 to both of the terms inside the parentheses. So now I've got 6t minus 4 is greater than 6t plus 10. Now that I've simplified, I want to try to eliminate t from one side. So we've got 6t's over here. Let's minus 6t's from both sides. Now this creates kind of an odd situation in that both sides had exactly 6t's. So as I do that, I eliminate t not just from one side, but from both. And now I've got this statement that negative 4 is greater than a 10. Well, that's absolutely false. That can't be true. A negative 4 is not greater than a 10. What this simple statement is saying is that there was no value, and there was never any value for t that could make a negative 4 be greater than a 10, meaning that there was never any value we could have picked for t that would have made this inequality true. No matter what value you pick, no matter what number you choose, the left side is going to be less than the right side. But that's not what the inequality says it wants. It says the left side has to be greater. So because there's no number we can choose that would make this true, there's no solution. All right, now let's move on to B. And notice once again, we've got those parentheses. We can use distributive property to simplify first. So we got 4x minus 6 is less than or equal to 9 plus 4x. We want to eliminate the x from one side, minus 4x's from both sides. Just like before, we see that we're going to eliminate all of the x's. This time, however, we got a statement that was true. Negative 6 is less than or equal to a 9. This is true. Now, as far as our solutions goes, what that means is that all real numbers are solutions. All the numbers you can pick are going to work here. Because if you got this 4x and in one way you subtract it and then in the other side you're adding a 9 to it, the side where you add a 9 is always going to be bigger than the side where you subtract a 6. It doesn't matter what number x was, this is always going to be true. So it's not just that we've got infinite solutions, because a lot of our inequalities have had infinite solutions. Here, it's that every number works, not just an infinite amount. Every single number you could pick is a solution to this inequality. So, to review, if you are solving and you eliminate all the variables through that process and you get a false statement, there are no solutions. If you solve and you eliminate all your variables and then you get a true statement, that means that every number is a solution, that it doesn't matter what number you pick, that inequality is always going to come out as true. All right, now let's look at a real-world context to this type of mathematics. So you've got your grades on 4 math tests. They're going to be 79, 85, 86, and 88. You want your mean grade, or in other words, your average grade, to be at least 85. So what grade on your 5th test do you need in order to get that mean score of at least 85? So first thing we're going to do are to relate these ideas. Now, it said at least 85, meaning if I get a 90, great, even better. So 85 is just the smallest amount that we would want to get. We don't want to drop below there. Maybe our parents take away our phone at that point. I don't know. But we want to make sure we're not dropping below the 85, but we could be anything above it. So our mean grade needs to be greater than 85. Now, the way you calculate a mean is you add up all the numbers, divide by how many there were. So we've got 5 tests here that we're dealing with. The 4 that we know and the 5th that we don't know yet, which is x. So we add them all up, divide by 5, and this needs to be greater than or equal to 85. Now, in order to solve this, first thing I'm going to do is simplify. I see a bunch of addition there in the top. I can do the addition. So adding all those numbers up, I get 338. Now comes the part where we need to start eliminating the numbers that are with x. Now, which order we pick here is a big deal. So once again, I want you to think about order of operations, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. First thing I would do here, now notice we've got all of the x plus 338 in the top of that fraction. So if I knew what x was before I divide by 5, I would do that addition first because it's all a single fraction. I can't do that division by 5 until after I know what x plus 338 is, meaning that the division by 5 is what happens last. What that also means is that in our solving process, it's what we're going to deal with first. The opposite of dividing by 5 would be multiplying by 5. This creates a 5 divided by 5 situation, which is just 1. Anything times 1 is just going to be itself, so we're left with the 338 plus x. 5 times the 85 is going to be 425. Now we just need to eliminate the 338. Because it's a positive 338, we can subtract it. Subtracting that from both sides, we get x is greater than or equal to 87. That means that we need to get a score of at least 87 to have a mean score of 85. All right, I hope this helped you. Good luck on your assignment.